Good morning children. In today's video we will be discussing preparation of alkanes. Various methods we are going to talk about, from unsaturated hydrocarbons, from alkyl halides and from acids, that is their salts. Okay, the first method which we are talking about is from unsaturated hydrocarbons. Unsaturated hydrocarbons means the ones which are having hydrocarbons. Unsaturated hydrocarbons means the ones which are having multiple bond, that is double bond or a triple bond. So basically this involves addition of hydrogen. You are adding H2 so as to get alkane. That means this is basically hydrogenation reaction. You are adding hydrogen to it. Okay, it is hydrogenation, or you can also call this as reduction, because addition of hydrogen is also reduction. So suppose you take alkene, say we are taking ethene, the simplest alkene. So to get alkane, that is ethane, we need to add one hydrogen to it. That means one H2 can be added to it, and the catalyst which we use here is nickel, platinum, palladium in the presence of hydrogen. So hydrogen I have shown you here. Okay, so nickel, platinum, palladium and hydrogen, right? So if it is nickel, you will have to heat it. If it is palladium and platinum, without heating, that is at ordinary temperature also it will occur. So that is the difference. In the presence of nickel, you will have to heat it. So you can just specify here that in nickel you will have to heat it, and if it is platinum or palladium, just at ordinary temperature also H2 will add on. So you will get alkane, that is ethane. So suppose you are using ethyne, that means triple bond. So in that case what will happen? You will have to add two hydrogen molecules. You'll have to add two hydrogen. In a way, first one H2 will add on in the presence of, say, nickel, platinum, palladium, whatever. Okay, you have to heat it. So this will add on. It will first result in the formation of alkene, that is double bond will appear, and thereafter if you add one more H2, the reaction will not stop here. If you want to stop here, then you'll have to use some other catalyst. Okay, so if you're using nickel, platinum, palladium, it will continue adding hydrogen till you get a single bond between two carbon atoms. Okay, so this is which category of reaction? We will say that it is hydrogenation of unsaturated hydrocarbons, or you can call this as reduction of the unsaturated hydrocarbons, right? And if you are carrying out the addition of hydrogen in the presence of nickel at high temperature, that means in the presence of this, the reaction is also called as Sabatier and Senderen's reaction. Reduction also you can call Sabatier Senderen's reduction reaction. Okay, it's a name reaction. Right? This particular reaction is also used in the manufacture of vanaspati ghee from edible vegetable oils. That is, hydrogenation is done in the presence of nickel. Right? The second method which we are considering is, the second method to prepare alkane is from alkyl halides. From alkyl halides. Alkyl halides means RX. Right. Now in this there are two methods. One method is in which you retain the number of the carbon atom. That means whatever carbon atoms you take in alkyl halide, the same number of the carbon atoms will be obtained in the alkane. Right. Suppose you take here RX, some alkyl halide, you will have to carry out reduction. So that means the first method which we are talking about is reduction of alkyl halide. It's reduction of alkyl halide, and that is generally done in the presence of zinc and HCl. Zinc and HCl. So what it does, that H of it will combine with it to form RH, and HX will be formed, that is alkyl halide will be reduced in the presence of zinc and HCl, and it will result in the formation of alkane. Okay. So basically, in the presence of this reducing agent, you'll get two hydrogens. One hydrogen with halogen will form HX, and the another hydrogen will R will form alkane. So suppose you are more specific, say you are taking one carbon atom alkyl halide, then you are using this zinc and HCl, you will get one carbon ka alkane. That means you will get methane. Methane plus here another H and this Cl will form HCl. It will form HCl. So whatever be the number of the carbon atoms you take in the alkyl halide, the same number of carbon atom alkane you will get it. Suppose you are using here 2 carbon atoms alkyl halide, you are using the same reducing agent, you will be getting 2 carbon atoms alkane, that is you are getting in this case ethane. The second method also from alkyl halide is a name reaction, that is Wurtz reaction. Wurtz reaction, which is a very, very important reaction. Now, in Wurtz reaction, what happens is you take alkyl halide, say you have taken alkyl halide, the reaction is carried out in the presence of sodium. It's carried out in the presence of sodium, and the another alkyl halide also we will write. We will understand the mechanism of this reaction, so this will be clear. The reaction is carried out in the presence of dry ether, not moist, because if you use moist, it will explosive. It will form a different product. So this will come out as NaX, 2 molecules of NaX, and this R and R will combine to form the alkane. In a way, in this reaction, you take here, whatever be the number of carbon atoms you take, in the product, you always get even number of alkane. I mean, even number of carbon atoms you get. Even number of carbon atoms are there in the alkane, that is the product which you are getting in this case. Okay, that is very, very important. That means if you take 1 carbon atom alkyl halide, so 1 carbon atom here, 1 carbon atom here, you will get 2 carbon atoms. If you take 2 carbon atom alkyl halide, 2 carbon atom here, you will get 4 carbon atoms. So you will never get odd carbon atoms in the alkane obtained by Wurtz reaction. So the basic format is this: alkyl halide will react in the presence of sodium. Will react with sodium in the presence of dry ether, and it will result in the formation of alkane with even number of carbon atoms. Right. Now let us understand the mechanism of this reaction. That is important to understand, the products, why odd cannot be formed. Right. And otherwise also some questions can be asked in different form where you need to understand the mechanism properly. So first what happens here is that sodium which we have taken, sodium undergoes ionization, and it will result in the formation of Na plus and electron. Because we wrote 2 sodiums, so let us write here 2 sodium only. It will give 2 sodium ions and 2 electrons also. We have taken 2 alkyl halides also, so let us write down 2 alkyl halides, right? 2 Rx. Now we know that halogen is more electronegative, so it will have a tendency to pull this electron pair towards itself. So this will have a tendency to get ionized as 2x minus, and when this breaks from here, this will form a R plus. That means it will result in the formation of R plus, that is R with a positive charge. That means a sort of a carbocation or carbonium ion it will form. Now this R plus which is formed here, that means 2R plus which was formed here, reacts with these 2 electrons. Because this is positive, it will take the electrons. So both the electrons it is going to take. This is actually carbon atom. I am writing here R means it is some alkyl radical. Okay, it's a carbon containing positive. So if you understand this way, the structure part of it, this is carbon. Actually, it is having a positive charge, means it is having 6 electrons with it. This R is having 6 electrons with it. To 2 R's, we are adding 2 electrons. That means the product which it is going to form is 2R with 1 dot only. Did you understand this point? There are 2 such carbon atoms like this. There is one more carbon atom like this, which I have shown you here. So this R or this carbon is getting 1 electron. This is also getting 1 electron. That means now it is having 6 plus 1, that is 7 electron. That means it has now formed a free radical. It has formed a free radical. So free radical is formed, that is R dot. Now 2 R dots are there, so R always has a tendency in the form of a free radical to combine with another such R. So one R, there are 2 R's, will react with another R, and R will combine and it will form R, that is alkane, which was formed here. So this reaction mechanism is a free radical mechanism. It is free radical mechanism which is proposed for Wurtz reaction. Right? Now you can understand the same thing with respect to some alkyl halide also. That is also not a problem. Now the question is, why did we use here dry ether? What was the use of it? See, we wrote here Na has undergone ionization. It has given out electron and it has formed Na plus. So some energy was required for ionizing it. Right? So initially it will ionize, and thereafter that Na plus which is formed gets surrounded by ether. What is ether? Basically RORs. So number of ethers will surround this. It's acting actually as a solvent. They surround the cation, that is Na plus. So in this process, what is happening between Na plus and that O of ether, there is some association. That means we can say this is getting solvated. Na plus is getting solvated. In that process, energy is released, that is called as solvation energy. So the energy released, that is solvation energy which is released, is required, it is used to ionize that Na to form Na plus. Okay, so that is the reaction, and the proposed mechanism is this. I hope you followed. First thing, Na undergoes ionization, and then alkyl halide will break because halogen being more electronegative will form halide ion, and then it will be forming R plus. That R plus, there are 2 R plus, both get 1 electron, so it forms a free radical. Okay, so when 2 free radicals are formed, they will combine and form alkane. And finally, this X minus and Na plus, they are combining and forming that NaX also. Right? Now, one thing I told you in the beginning only, that Wurtz reaction is only applicable to prepare alkane with the even number of carbon atom, not for the odd number. What might happen if we are using odd number? Suppose I use this methyl bromide in one as one reactant, 2 Na, and the another one which I am taking is ethyl. Suppose I am taking ethyl and I am trying to carry out the reaction in the presence of dry ether. Then what normally you expect is this will come out as NaX and you will get NaBr, and then propane should be formed. But no. Because when this is getting ionized, this part will form methyl free radical. This part will form ethyl free radical. Right? So when these radicals are available, there is a possibility that one methyl can combine with another methyl of the same type to form ethane. Or another possibility is this ethyl may combine with another such ethyl, and it may result in the formation of butane. It may result in the formation of butane, or they may combine with each other, that is methyl may combine with ethyl. So in that case it will form propane. That means if you take a mixture of the alkyl halides, you are taking 2 different alkyl halides. If you take 2 different alkyl halides, you will get a mixture of the products. Either 2 methyls only combine you will get ethane. Only two ethyls may combine, you may get butane, or ethyl methyl may combine, you will get propane. Okay, I just wrote the same thing as the radicals directly, but the mechanism is as I have discussed earlier. Okay, so this type of reaction, that is Wurtz reaction, will be more applicable to prepare the alkanes which are of the symmetrical type. Symmetrical type means, suppose I want to prepare this type in terms of the bond line notation. Say if it is given this, can I prepare this? Yes, I can prepare, because you can break it into two halves. Can I prepare this one? Can I prepare this one? No, I cannot prepare because it is not symmetrical. Can I prepare this one? Yes, I can prepare, because I can use ethyl and ethyl, it will form butane. Okay, so you can prepare only those alkanes which are having even number of carbon atoms, not odd. Now moving on to the third method of preparation of alkane, that is decarboxylation. D means removal. Carboxyl means COO group. So COO group is to be removed in this. Right. Now suppose I write the general, reaction in terms of R. Suppose I write, say, RCOONA. What you take in decarboxylation is, you take a salt of the carboxylic acid. Sodium or potassium salt. Normally you take sodium. Salt of carboxylic acid you will take it, and you will treat this with soda lime. Soda lime. Now what is that soda lime? Soda is from caustic soda. Caustic soda, NaOH. And this is lime, quick lime. Okay, so these two are taken, and you can just see how they are forming the product. This is the easy way to learn. Otherwise mechanism also we will discuss. It will form RH plus sodium carbonate, that is Na2CO3. That means it will form alkane plus sodium carbonate. Very, very important thing in this is that you are getting a product with one carbon less. That means this particular reaction is used for descending the alkanes. In case you are asked that you want to prepare the alkane with less number of carbon atoms, then you can make use of this decarboxylation reaction. A very important reaction for descending, getting less number of carbon atoms. Okay, now actually what is the mechanism of this reaction? Let us understand the mechanism. Okay, so what exactly happens in this is, suppose I write here RCOONA. It is sodium salt of carboxylic acid. So this is ionizable. It can ionize and form carboxylate ion plus sodium ion. Okay, so now this carboxylate ion which is formed, let us open the structure and write COO. This thing is there, minus. So what happens in this is, this negative charge which is there on oxygen atom, it moves this side, it shifts this side. When this shifts this side, the carbon valency is complete now. It is having complete 4 bonds. So this particular bond between R and carbon will shift towards alkyl group. That means this bond is going to break from here. So when it breaks, just see what is it going to form. This comes here, means you are having carbon double bond here. Here you already have a double bond. So that means apart from that, this has gone here, means it has now formed R minus. That means carb anion is formed. What is this product formed here? This is carb anion. Carbon containing a negative charge is formed. Right. Now this carb anion, that is R minus, is undergoing hydrolysis. That means here in this you are taking a solution of it. You are taking a solution. So this is undergoing hydrolysis. So when this is undergoing hydrolysis, what is happening? This water is H and OH. It's H plus and OH minus. So this H plus from here will combine with this R minus, and it will result in the formation of alkane. That is what we were looking for, RH. So alkane is formed. plus this OH minus is released from here. Fine. Now what happens finally is this Na plus and this OH minus will now combine. Na plus plus OH minus will combine and it will result in the formation of NaOH. We used in the beginning NaOH also. So that on NaOH and this NaOH both. There are two NaOH now. So this NaOH plus that previous NaOH which we took, both these NaOH will combine with the carbon dioxide which was formed here as one of the product. It will combine with the carbon dioxide as the product which was formed, and it will combine and will result in the formation of sodium carbonate, Na2CO3 plus water is again obtained back. That is hydrolysis in the presence of what we carried out. Okay, so what is the major product here? Alkane we got plus you got sodium carbonate. This was there formed in the equation and which has again combined to form finally this one. So you are having two main products, alkane plus sodium carbonate. Right. So whenever we want one carbon atom less, you will get this. Suppose you want to carry out decarboxylation with 3 carbon atom salt. Say this one you are taking. And of course you are carrying out the reaction with soda lime in the presence of CaO. For writing part you will just write like this, ki sodium carbonate is formed, Na2CO3. Apart from that you can say 2 carbon atom ka alkane is formed, that is ethane. Okay, this is decarboxylation. So please remember this reaction properly. It will be required for making an alkane with less number of carbon atom. Moving on to the next method, that is Kolbe's electrolysis. Kolbe's electrolysis is done for a salt of carboxylic acid. Right. So to remember, you can remember like that. Say we are using sodium salt. You can use potassium salt also. Sodium acetate. So you will write down 2 molecules of sodium acetate. You will use its aqueous solution, because to carry out electrolysis you have to make a solution and then electric current is passed through it. We cannot use here simply acetic acid, because acetic acid is a weak acid, will not ionize easily. So sodium salt you take which can ionize easily and it can allow the electric current to pass through it. Right. So if you are remembering the products, simply what you will do is these two will combine and form ethane, that is one of the product, that is CH3CH3. These two will combine and they will form 2 molecules of carbon dioxide. Then Na and water will combine and form NaOH plus hydrogen gas will be released. That is one way of remembering it. You always see that in this you are getting alkane with more number of carbon atom. You have used 1 carbon here. Yes, in the salt, if you are taking 1 carbon atom alkyl this side, 1 carbon atom alkyl this side, you will be getting 1 alkyl from here, another alkyl from here. So total you will get 2 carbon atom. Don't get confused that way. If you are having total 2 carbon, you are getting 2 carbon only. That means by this particular method, that is Kolbe's electrolysis, methane cannot be prepared. You cannot prepare methane by Kolbe's electrolysis. You will always get the alkane with even number of carbon atoms. With even number of carbon atoms only you will get. So these are the 2 important points. First of all, methane cannot be prepared and you can get only alkane with even number of carbon atoms. Now let us understand the mechanism of this reaction. What exactly happens in this reaction in Kolbe's electrolysis. So first thing is we have used 2 moles of it. So we will write down 2 molecules of sodium acetate. They will ionize. So when they undergo ionization, it will form 2 Na plus ions and 2 acetate ions. We have used water also. So water also will undergo ionization. So 2 moles means this also should be 2. Of course, you can balance it accordingly. So 2, it will give 2 H plus and 2 OH minus ions. Okay. Now, we know that anions move towards anode and cations move towards cathode. So first, anions. Anions are this acetate ion. This will move towards anode, right? So what will happen? Two acetate ions will lose 2 electrons. They will lose 2 electrons. There are 2 acetate ions. Both will lose 1 electron. So when they lose 1 electron, what will be formed? They will form free radical. They will form 2 free radicals of acetate. Then what happens in the next step is, let me write down this acetate in this manner, COO. You have O here, you have one odd electron present here. It's a free radical of acetate. Now what happens is, this odd electron moves this side, tries to make this carbon double bond, but with just 1 electron it cannot be double bond. So this side carbon alkyl, that is methyl bond, 1 electron will shift this side, so that between these two carbon and oxygen atom there is 1 complete bond, and 1 odd electron left over here will shift towards methyl. I'll repeat, this odd electron from here, that is this one, is moving towards the bond between carbon oxygen, and this particular bond divides into 2 halves. 1 electron goes this side, another electron goes on methyl. Just see now what is formed. So when this has gone here, this has gone here, it has formed 2 molecules of carbon dioxide. Apart from that, there are 2 methyl free radicals also generated. 2 methyl free radicals also generated. So these 2 methyl free radicals now will combine and will result in the formation of ethane. 1 methyl, another methyl, both will combine and they will result in the formation of ethane. This is the reaction that is taking place at anode. Now let's see what is happening at cathode. At cathode, what is happening? The cations will move towards cathode. This is one cation, this is another cation. So when 2 cations are there, the one that can be discharged easily is obtained. So first H plus is obtained there at cathode. So 2H plus will combine with these 2 electrons, here it was plus, will combine with these 2 electrons and result in the formation of hydrogen gas. So that is the hydrogen gas which we wrote over here, H2 was released. Apart from that, at cathode you have Na plus also. You have Na plus also. So that Na plus which is obtained here, right? So this Na plus which is obtained here will also combine with this OH minus. So these two will combine with each other and will result in the formation of NaOH. That means this plus 2 OH minus will result in the formation of 2 molecules of NaOH. That means base is formed in the reaction. Now just see, observe what products we wrote there. We wrote one product as ethane. This is one product which was formed. This is first product. We wrote carbon dioxide. Yes, you got 2 molecules of carbon dioxide. This is the second product which is obtained. Then we wrote NaOH. You are having 2. This also when you balance it, you will get 2 only. Yes, so 2 molecules of NaOH. Then you also got hydrogen. So that is also the fourth product. This is the third product and this one is the fourth product. Got it? Now in this method the base is also formed. So we can say in Kolbe's electrolysis the pH of the solution also increases because the base is formed. So other 2 points I already told you in the beginning, that one thing is it always prepare alkane with the even number of carbon atom. Methane cannot be prepared by Kolbe's electrolysis. The second thing I told you is only even number of carbon atoms. Alkane can be prepared by this method. Okay, another thing I told you is the pH of the solution increases. So overall you can see we have done 3 main methods. One was from unsaturated hydrocarbons, that is hydrogenation. Second, from alkyl halide. In alkyl halide, we have done two different methods. One was reduction, another is Wurtz reaction. Then the next one was from these carboxylic acid salts. In that also we have done two. One decarboxylation and another one we have done is Kolbe's electrolysis. Okay, so please practice these preparations of alkanes. Write and learn, otherwise you will forget organic chemistry. Okay, thank you.